Okay, this is problem 3-31. Here you have a lap joint connected together using a 1.25 diameter bolt. You have 150 kip load being applied here, which means you'll have 75 coming out of this member and 75 coming out of this member here. You have two ways to solve this. You can take the bolt and put it in double shear, or put it in single shear if you use the 75. So what I'm going to do is to find the shear stress. I'm going to use the 75, and all I have to do is do pi d squared divided by 4. The diameter is 1.25. I square that, divided by 4. That's going to give me a shear stress of 61.12 KSI. Again, if you want to use the 150 and put it in double shear, you're going to get the same thing, except you're shearing across two areas. So just do pi times 1.25 squared divided by 4. Again, that's going to give you 61.12 KSI. Alright, so now what you have to do now is go find out where 61.12 KSI is on the shear versus strain curve. And if you do that, you'll find out you're somewhere above the 50, so you're somewhere out in this area right here. Alright, so what we want to do here is we want to find out what the strain is. We know the shear stress, and we'll label that as 61.12. So all I have to do is come down here on my strain and find out what that value is right there. So to do that, basically you know what the slope of this is. You know the slope is going to be 75 minus 50 over 0.05 minus 0.005. All you have to do is to set that equal to 61.12, this value here, minus this. You can do rise over run over this strain value here, minus the 0.005. Okay, if you find that value, you'll find out that the strain is going to be 0.02501 radians. Okay. Now, what you're going to do there is, you know this value here. And we'll move this one down. This value is 0.02501 from here to here. Now what we're looking for is the permanent set. And to find permanent stress, permanent sec, you're going to bring this slope back. It's going to be parallel to this slope here. This right here is going to be your permanent value. That's what we're looking for. Alright, so now to do that, all we have to do is try to find out what the slope of this curve is going to be. By doing that, I'll scroll down here. All I have to do is do rise over run again on that, and I'll get 50 divided by 0.005. That'll give me a value of 10 times 10. Let me erase that. Give me a value 10 times 10 to the third. Okay, and that's going to be my shear modulus right there. Again, that's going to be into KSI. Okay, so now I know what this value is here, so all I have to do really is to try to find out what this is going to be right through here. So to do that, all I have to do is to take my shear, set it up to my slope, times my shear strain. Again, all we're really doing is y equals mx. That's all we're doing. Because for y mx plus b, but b is 0, y-intercept. So when you do that, that's going to give you your 61.12. Set that equal to g value, which is going to be 10 times 10 to the third. Solve for your elastic shear strain, and when you do that, you'll find out that this value right here is going to give you the 6.112 times 10 to the minus 3 radians. Again, that value is going to represent right through there. So now all you have to do is to take the value calculated earlier, the 0.02501, subtract 6.112 times 10 to the minus 3, and that'll give you 0.0189 radians. And that's going to represent your permanent set. Erase that better there. Alright, so that's all you have to do on that one. It's really not that bad. It's more of a it's more of a slope type problem here. So just remember, this part here is your permanent set, and this is going to be your elastic area right here.